Hello and welcome back to another episode of Math with Zone. Today we are going to be graphing quadratic equations or parabolas when it is in standard form. Well, standard form, the most basic version of that would be a y equals x squared, maybe like minus 6x plus, let's say, 3. Okay? Now, when it's in standard form, it is very important that you recognize the formula negative b over 2a. That is the formula that is going to save your life. And the a is the number in front, and the b is this number right here. And technically, this is your c, but it's also your y-intercept. The c and the y-intercept are the same thing. So we're going to do that, negative b over 2a. So negative b is going to, in this case, be a negative 6 over 2 times 1. And when you do that, you are going to get the x value of our vertex. So this is the x value of the vertex of the parabola. So if we do that, if we do negative 6, we're going to end up with, that's 6 divided by 2. 6 divided by 2 is 3. And that is, of course, the x value of the vertex. And we still need to find the y value. You get the y value by just plugging in x. So we're going to plug in the x. We're going to do 3 squared minus 6 times 3 plus 3. A lot of 3's. That 3 was already here, which makes me almost want to change it to an 8. 9 minus 18 plus 3 gets our final answer, which these are always going to be opposite signs and half of one another, just so you're aware. 9 minus 18 plus 3 ends up being negative 6, I think. Yep, negative 9 plus 3 is negative 6. And that, ladies and gentlemen, is our vertex, the most important point potentially on a parabola. And now we just have to graph it. If our goal is to graph this, we would need to go to the right by 3 and down by 1, 2, 3, 4, 5, 6. And you have to pay attention to the A to determine if this faces up or down. If the A is positive, which this one is, it will face up. So we are going to graph this facing up. We are going to be symmetrical. And there's one other key point that is very useful, and that is this. The last number is your y-intercept, which is apparently at positive 3. So I should have a y-intercept up here at positive 3. And if we graph from that y-intercept and the vertex, making it curve up from there, then we would just have to be symmetrical in the other direction, so that right here, when we I think we went to the left by 3, we would also go to the right by 3, and be able to get that symmetry that we needed. So this point down here is at 3, negative 6. And we have our graph. On a different video, we're going to go over all the other things that you could have to have for the graph. For instance, I'm just going to go over a few of them. This is the min or the max. And we do have this symmetrical line known as the axis symmetry. So we're going to go over all the other key features, the domain and range, and all that stuff from a different video, so it's isolated. Today, we're just going to focus on the graphing part, or at least in this video. So another example, we're going to do one more, at least maybe 2 more. Let's say we have y equals 2x squared minus 12x plus 5. That's our B. That's our A. This is our y-intercept, technically our C. We start by doing negative b over 2a. So that would be negative 12 over 2 times 2, which ends up being positive 12 over 4, which of course is 12 divided by 4, or 3. So it's again a 3. Apologies, they're all 3 today. Plug in the 3 for both x values. You get 2 times 3 squared minus 12 times 3 plus a 5. Do the math. You end up with 2 times 9, which is 18, minus 36. Again, half of one another or double one another and opposite signs. It doesn't You don't know which one's going to be negative, but they will always be the bigger number here and the smaller number there, plus 5. And that is equal to negative 13. Yeah, that's a bad-looking 13. Negative 13. So we have our vertex is at negative 3, comma, negative 13. We can plot that point. Not negative 3, positive 3. 3, way down there at 13. And this graph also faces up, so it is going to be going up and up. But before you go completely up there, you need to make sure that your y-intercept is in the correct location. If your y-intercept was trying to force you to go down, then you would need to rethink what happened. Oh, I missed. I'm trying. There we go. So at positive 5, and there we go. So one more. Let's do one more. All right, the last one is slightly easier, but it is one of the most missed questions because it just happens to be one of those things where sometimes the easier bits make it harder. And in retrospect, with that in mind, I might do another bonus problem at the very end. So let's say we got y equals negative x squared plus 6x. We'll go with plus 7. Okay? Negative 6 over 2 times negative 1, because we still have to do negative b over 2a, ends up being negative 6, because changing that becomes negative 6. 2 times negative 1 is, of course, 3. It's the theme of the day. The x value apparently has to be 3 if I'm making up problems in my head. Plug in the 3. Negative 3 squared. Notice how the negative is on the outside of the parentheses. I'm not plugging in a negative 3. It's being plugged in for that x. Plus 6 times 3, plus 7. This is where that trick of knowing they have to be opposite signs and half of one another really comes into handy, because if you did negative 3 squared, it ends up being positive 9. And here, 6 times 3 is 18. So half of one another, opposite signs, we end up with 9 plus 7, which is 9 plus 7 is 16. 1, 2, 3, way up here at 16. And this is our first graph that should face down because it is negative in front. If it's negative in front, it has to face down. Our y-intercept is 7. I'm going to say 7's right about there. And we are just going to curve this parabola facing down. All right. One more bonus problem. As promised, this one's going to be the easiest of them all, but it is going to be different. So let's say we have y equals, let's go with negative 2x squared minus 16x. Okay? So if we have that scenario, then when we do our negative b over 2a, we have to just be aware that there's no c. The y-intercept is 0. But sometimes you won't have a b. So just be aware, if there's no b, that's 0 as well. For instance, if I had y equals just x squared minus 4, the b would be 0. Okay? Here, the b is existing, and the b in this case would be positive 16. When we do negative 16, it would be positive over 2 times negative 2, which ends up being 16 over negative 4, which is not 3. It's negative 4. 16 divided by 4 is 4, so 16 divided by negative 4 is negative 4. Plug in negative 4 to negative 2 times negative 4 squared minus 16 times negative 4 plus 0. You don't need the plus 0. You can include it if you want to. Negative 4 squared is negative 4 times negative 4. If you don't put that in parentheses in your calculator, it will tell you that that is negative 16. But negative 4 times negative 4 is positive 16. If you don't put it in parentheses, your calculator will do the wrong thing. You have to put it in parentheses. 16 times 4 is a number. It's a big number. It's a number that I'm getting a calculator out for. 16 times 4 is 64. It's not that big, I guess. Plus 64. I'm not writing plus 0. 2 times 16 is negative 32 plus 16, plus 64. Make sure they're half of one another and opposite signs. If they are, then you're on the right path. And this will add together to equal 32, which gives us our y value. Plot the point at negative 4, way up here at 32. And then make sure your y-intercept is plotted as well, which is at 0. So this graph would face down, and it should as well because it's a negative in front. And if you want to be ultra specific, you should maybe even be like, well, this is going to be at negative 8 because this is symmetrical, of course. If I went 4 to the right to get to this y-intercept, then I'd have to go 4 to the left to be symmetrical at that moment because this should be symmetrical around the vertex. Okay, so that's going to do it for this one. We are going to have another video on this stuff relating to the domain, the range, the axis of symmetry, min and max, and all the other vocab that can go along with it as well. All right, till next time, I will see everybody later, and stay positive, my friends. Bye.